User Datagram Protocol, or UDP, is one of the protocols used in the transport layer. Being a protocol in the transport layer, it has to perform all necessary functions assigned to the transport layer. It includes addressing, end-to-end delivery, multiplexing and demultiplexing, and it also includes some kind of error control. As in other protocols, UDP includes some control information at the beginning of the data in order to accomplish the functions assigned to it. This control information included in the beginning of the data is called header in general and UDP header in particular, because it is added by UDP protocol. That is why it is called UDP header. In this video, we will explore the UDP header and we'll see how this protocol uses the header in order to accomplish the task assigned to the transport layer. The data unit in transport layer is called a segment. The segment is also known as a datagram when we discuss the segment in terms of UDP protocol. So throughout the discussion, we will use this term segment and a data segment or datagram, segment and datagram interchangeably. Sometimes we'll be using the word packet, but mainly we are talking about the segment or datagram in this video for discussing the concept of UDP header. The UDP adds 32-bit control information in the front of the segment. These 32 bits are partitioned into 4 different parts of 16-bit each. These are called UDP header fields. In the figure here, all different fields are shown. One is the source port, destination port, length, and checksum. These are 4 fields of the UDP header. The same diagram is shown in a different presentation. All the fields of the UDP header are shown horizontally, and the first field, the source port, it is of 16-bit, then it comes the destination port of 16 bits, then the length and the checksum. Now let us see how these different fields of UDP header helps in performing the functions of the transport layer. The first function, if we remember, or if we recall the first function of the transport layer, is addressing. The first function of the transport layer is addressing. Addressing means the addressing of end processes. These end processes is one who produces the data and it resides in the sender side, and another is the consumer of the data. Which resides in the receiver side. This addressing of end processes are done with the help of source port number, who identifies the end process in the sender side, and the destination port who identifies the consumer of the data in the receiver side. That means the source port and destination port performs the function of addressing in transport layer. Then other function includes the multiplexing and demultiplexing. These two functions are also done with the help of the port numbers. So addressing and demultiplexing and multiplexing, these two functions of the transport layer is done with the help of port numbers. Then the other important function in the transport layer is error control. As stated earlier, that UDP is a very simple protocol in the transport layer, and it does not provide any reliability or guaranteed service. That is why the header does not include much information or much control data or control bits in order to provide such reliable transmission. However, there are two fields which is used to find the error up to some extent. These two fields are the length and the checksum. The length field, it helps in determining the correctness of the segment, correctness of the datagram by finding the boundary of UDP packet. Means it gives the total number of bytes in the datagram for that specific UDP protocol. So this length includes the 8 bytes header plus the data included in the packet or the datagram. So total number of bytes are included here, and what the receiver will do, receiver will scan or read only the total number of bytes from the starting of the datagram which has been identified by the length field. If it exceeds or if it lesser than that given data, that length of the datagram, then the datagram is considered as not correct. And this is maybe considered as one of the method of providing some erroneous datagram or error-free datagram. The second field which is used for error control is checksum. This checksum field carries some value. That value is calculated by the source when the datagram is constructed or prepared, and in order to find the checksum of the segment, it adds the bit pattern of the entire datagram, and resultant value is put in the checksum field. And in the receiver side, what the receiver will do, the receiver will, after reception of the datagram, recompute the checksum, and it compares with the datagram. It compares the checksum which is included in the datagram and the datagram checksum of the datagram which is being computed by the receiver. And if the comparison evaluates true, that means both the checksums, one is received and another is computed, are same, then the segment is considered as a valid segment. Otherwise it will drop the segment and no further steps are taken care of by any of the sources or the destination. That's why it is considered as unreliable. So the protocol will try to deliver the packet, but there is no guarantee. That is why it is called a best effort service. The basic characteristics of UDP are: it is a connectionless and fast protocol. It does not guarantee in-order delivery. It also does not provide congestion control. The header structure includes 64 bits, which is divided into 4 different blocks or fields: source port, destination port, length, and checksum. Each of them are of 16 bits. If this protocol is not reliable and it is connectionless, it does not provide congestion control, then is it really useful? If it is useful, then where do we use it? And this UDP protocol, although it is connectionless protocol, unreliable protocol, still it is used because of the fact that it is a very fast protocol. Compared to other existing protocols, any application who uses UDP as the transport layer protocol works faster compared to other existing protocols. That is why in most of the applications where reliability is not important, the UDP protocol is used. Moreover, if the application where the overhead need to be nearly zero or lower, overhead need to be lower for data transmission, where first transmission is required, in that cases UDP is selected for the transport layer protocol. Few of the examples where the UDP is preferred, it is DNS, which is a domain name services. This protocol is used for converting URL into IP addresses. This protocol does not need any reliability. However, the fastest transmission is required. That's why DNS uses UDP protocol. Few of the routing protocols like RIP, OSPF, these are the widely used routing protocols for internetworking. These two protocols also uses the UDP as transport layer protocol. Trivial file transfer protocol, this is a protocol which is used for transferring file from one location to another, and that protocol also uses UDP protocol. Multimedia transmission or video conferencing, it uses UDP protocol. Moreover, the DHCP used for auto configuration of IP address uses UDP protocol. Overall, UDP protocol is used in many applications where the reliability is not that important. However, timeliness or fastest transmission of the data packet is essential. In that type of applications, UDP is preferred over other transport layer protocols.